All right, and we're back. Hopefully you got a coffee and we're ready to keep going. So we talked about the UI stuff, we talked about data models, and now we're sort of in the middle of going through some of the platform-specific features and comparing Windows 8 and Windows Phone 8. Now, I'm told that one of the questions that's been asked a few times is where can we get the source code and so on, and I did mention there were some resources, and so I'm kind of forward referencing some of the stuff I was going to talk about at the end. And so if we look at this slide here, this is the additional resources. I've actually created a bit.ly bundle, and you can get to it at bit.ly, so bit.ly/build for both, with a capital B, a capital F, and a capital B again. If you go there, you'll see a whole long list of links that you can get to, and that should include the source code. It also includes links to all sorts of interesting stuff that you should keep in mind. And so it's a really good sort of a go-to resource when you're looking for, or when you're thinking about building for both Windows 8 and Windows Phone. Okay, so let's get back to, let me just switch back to my other PowerPoint and continue where we had left off. And so we had just seen, last week's episode, we had just seen the application lifecycle, and we'd gone through a demo. And so now we're going to continue on and look at some of the other platform-specific features and compare and contrast those between Windows Phone and Windows 8. There is some built-in support for common operations in both Windows 8 and Windows Phone. In Windows 8, they are called contracts. In Windows Phone, there's something that's similar called tasks, although the developer experience is quite different. So you might call me on comparing those two, but they sort of try to do the same sorts of things. And so I in my mind, I sort of, if I am doing contracts, some of the things that I would do with a contract I would do with tasks. And so it basically involves coordination of stuff that your app needs to do with the operating system. So the task approach, Windows Phone APIs are found in the Microsoft Phone.tasks namespace. So things like the photo chooser task, email address chooser task, save a contact task. There's a whole slew of them. There's probably 20, 30, maybe more tasks that are available. And so between tasks and choosers, you have a bunch there. Windows 8 has a number of individual APIs that are collectively referred to as contracts. And basically, you, by defining and declaring those contracts in your manifest, you're basically telling Windows that you are going to adhere to this contract to do things like sharing or searching or play to or any one of the other contracts. And these tend to be related to what you would normally see on the charms bar, so things like, as I mentioned, search and share and so on. The Windows 8 contract is essentially an agreement, as I said. It's an agreement between your app and the operating system that when the operating system wants you to do something, it expects you to do it in a very specific way, and you implement that in that very specific way. Implementing the contracts means you override certain methods in the application class, or you handle certain events in various classes. And depending on the app, the user may actually expect some of those contracts to be there. And so certainly I would encourage you wherever possible to take advantage of the contract. It just makes your app feel more like a native Windows 8 app, and so you should take advantage of that. So the typical ones, search and share, are the two that you should be looking at absolutely. Settings is another one, Play To is another one, and so on. The other area, and this is sort of the, I would even call it the defining feature of both Windows Phone and Windows 8, is live tiles. And live tiles are the entry point for both Windows 8 and Windows Phone 8 apps. And so your primary tile is what would normally launch your application. Now, of course, Windows 8 also has the app list, but for the most part, the live tile is what your end users will see as sort of the entry point into your app. There's also the concept of secondary tiles, where rather than starting an app, you're not only starting the app, but manipulating the app via the data within the app, if that makes sense. Both platforms, both Windows 8 and Windows Phone 8 support live tiles, and both of them support secondary live tiles. And both of them support the idea of periodically updating the tiles so that they appear live and interesting and are a clue to the end user to come back and start your app again. Again, if there's any way that you can do that in your app, certainly from what we've seen, apps that take advantage of live tiles tend to get downloaded more, tend to get used more, and tend to get preferred over competitors that don't have live tiles. So it's a good way to get more downloads. Again, both platforms support tiles, but the APIs are completely different between the two. And so unfortunately, it's pretty hard to reuse live tiles, either the tiles themselves or the code that you would do that. So let's look at how they're different. On Windows Phone side, there are actually 3 sizes of live tiles. There's the small, medium, and wide live tile. These are new to Windows Phone 8. We used to have just medium. Now we have small and wide as well. Windows tiles, there's only 2 sizes. There's medium and wide. In Windows Phone, you have several templates that you can define for your live tiles. And the standard ones are flip tile, cyclic tile, iconic tile, and then there's this just standard tile where you define exactly what you're doing. On the Windows side, secondary tiles are defined and customized by XML templates. And so it's a little different in the way you do that. You provide tile images in the manifest in the Windows Phone side. It's the same way on the Windows side, so that's one similarity. You can create secondary live tiles using a static method, the shell-tile.create in Windows Phone. On Windows, you use a secondary tile.request-create async. Again, totally different API there. And then updating the app tile on Windows Phone is done using the shell tile, in the Microsoft Phone.shell API. And in Windows, you use the tile update manager and tile notification in the windows.ui.notification namespace. So again, totally different. One other area that you should keep in mind is that on the Windows side, the end user can actually turn off your live tile and turn off notifications so that your live tile, even if you have one, and even if they've pinned it to the start screen, if the end user decides they don't want to see a live tile on your app or on any other apps, then they can turn that off. So it's something you need to keep in mind, and you need to check for that before you try to update your tile. So let's look at the differences there. You can see here the comparison of a secondary tile creation. So here we're using a cycle tile data, so it's the cycle tile template. And we're giving it a title, we're giving it the background image using a URI, and giving it a list of images that it can cycle through as part of the cycle images. The cycle image template is the same one that you may have seen as it's the one that the photo app uses to cycle through. I think it has 8 images that it cycles through. So that's how you define the template, or what your tile information is, and then you use the shell-tile.create, give it the URI, give it that tile data, and the operating system that goes off and creates that for you. Windows, it's actually a little bit easier. You new up a secondary tile, give it a unique ID that it can be referred to as, a short title, a long title, activation argument, and then there are some options that you can define. In this case, we're showing the name on the logo, and then giving it the URI to the image, to the logo of the tile, and then you use the request create async method to create that tile. So you can see they're completely different in the methods that you're using to create those. And so, again, it makes it a little bit more difficult to share code among those two. Another area, and this is sort of tangentially sort of similar or related to tiles, is the idea of notifications, or notifying the user. It's another way of you getting in front of the end user and telling them that something needs to happen, or that they need to take some sort of action. You alert the end user to that using notifications. In Windows Phone, you also have the concept of reminders. We'll talk about those as well. The one thing I would caution you if you are using these is try not to overuse them. They are very intrusive. They basically get in your face, and if you overuse that, the end user may get annoyed with your app and turn off your notifications, or worst case, they may actually uninstall your app. So use them sparingly, and when you are using them, make sure that there's actually some real action that the end user should be taking, or some important information that the end user has asked you to give them. And even within your app, you should give the end user the option of turning these notifications on or off, so that, again, they're not tempted to go and uninstall your app. Notifications, Windows 8 supports two kinds of notifications. There's reminders and alarms. These are ways of bringing information to the foreground so the end user can see it, and this would be in the foreground even when your app is not in the foreground. You can also use toasts to do that, using the shell toast, and that again can be shown from the background. The alarms and reminders are in the Microsoft.phone.scheduler namespace, and the shell toast is in the Microsoft Phone.shell namespace. Windows 8 uses toast notifications, and it's a little bit simpler. You use the toast notification manager and the scheduled toast notification. You have to enable these in the manifest, and I'll show you how to do that in a second. And you have to give it a template. I think there's I think there's 8 different templates that you can use, and they're basically defined in XML, and you choose one and then hand that to the API call, and it handles creating that toast for you. Okay, so let's actually have a look at that. I'm going to switch to Visual Studio here. And so again, we're going to use the Contoso Cookbook. Let me start in Windows Phone this time, and I will go to Common. Here it is, features.cs. And here you'll see that there is a set reminder API or method as part of my notifications class. And so let's just walk through this quickly. It's actually pretty trivial. This is this gets called when you tap the reminders on the app bar, and it's actually a toggle. So the first thing I do is I check if there already is a reminder scheduled, and I'm calling this method, then it means the end user wants to turn off the reminder. And so you can see here where I'm actually using the remove method to remove that reminder. But let's go through how to create a new reminder. So I'm checking to see if it exists. If it does exist, I'm removing it. And then I am I'm newing up a reminder, giving it a unique ID so that I can find it later and check for it later, giving it a title, giving it some content. In this case, it's a reminder for a cookbook app, and so it's a reminder. Typically, you would click it when you want to set a reminder because you put something in the oven or something like that. And so that reminder would come based on the amount of preparation time for a particular thing. And then this is some debug code. So if I am using the debugger, rather than having to wait 30 minutes, it just uses a begin time of 1 minute. Basically, it's telling me that the reminder will be 1 minute long, or 1 minute from now. Or if I'm actually running the code in production, then it's actually getting the item prep time and using that to set the reminder time. And then there's the begin time, there's the expiration time. There's a recurrence type. In this case, there is no recurrence, but I could set it to be a daily recurrence and so on. That's not something you would do in a cookbook app, but obviously something you might do in a calendar app, for instance, that sort of thing. And then there's a navigation URI. The navigation URI is important in that in Windows Phone, when the reminder comes up, if the end user actually taps the reminder, it can actually relaunch the app and bring you directly into a particular page deep linking directly into a particular page in the app. And so it could actually launch the app and bring me to that recipe so that I can continue doing what needs to be done. And so that's kind of handy. It means that when I get the reminder, I can take action on it right away. And then once I've created that reminder, then I basically use the scheduled action service to add that reminder. And then there's some interesting stuff here. This is more related to the in-app purchase. We're not going to talk about that today, but that's generally it. And then, as I mentioned, there is because it's a toggle, the scheduled action service, the same way we use the add to add the reminder, there is a remove to remove the reminder, and it's the same thing. It's just basically removing it. So that's how you do it in Windows Phone. Let's have a look at how you would do a toast notification on Windows 8. So let me switch over here, and I will go to the item detail page, and let's see. There should be an on reminder. There it is. I missed it. Okay, there it is. Okay, so the on reminder button clicked, and so here it's an app that's a cookbook again. When I click the reminder, it will basically set a toast reminder that will then get shown when that event is triggered. So I'm using the notifier toast notification manager to create that toast notifier, making sure that notifications are enabled. Remember, I said this earlier, the end user may have, let me just show you here. If I dive in, you can see this notification setting. It can be disabled for application, disabled for user, disabled by a group policy even, or disabled in the manifest. You may have actually forgotten to turn it on in the manifest, in which case it's just never going to trigger, because if it's not in the manifest, then you can't run that code. So I'm checking for that, and if it does do that, then in this case I'm just popping up a message dialog that says, sorry, I know you want a notification, but I can't do notifications because they've been turned off for whatever reason. But if I can, then I'm creating a toast template. Remember, I said there were, I think, 8 different templates from toast from 0 to 8 of one sort or another. The toast text 1 template is a very similar, again, I think I can dive in and show, yeah, there's the 8 of them there. There's different kinds of templates based on how much text you want and whether you want the text to flow across 3 lines, or you want a title with 2 lines, or just 3 separate lines, whether you want an image on the left or not. And so you decide that, and once you've decided that, you choose that template. In this case, I'm using the toast text 1, which is essentially text that flows across 3 lines and then gets clipped. And so I am checking the element. I'm adding the reminder to that, and then I'm scheduling it. So here I'm checking I'm defining the date of when I want that to happen. And then I'm doing a scheduled toast notification, calling it STN, giving it the template and the date. And then once I have that scheduled toast notification, once I've newed that up, I just hand that to the notifier with the add to schedule method. And then and then in this case, 30 seconds from now, I will see that toast pop up. So pretty straightforward. I should show you that there is a, let me see if I can find the, here it is, package. Oh, I had it open already. Here's my manifest, and you can see here that in the badge logo, there is toast capable, right? So here I'm telling the app whether I am going to allow, sorry, I'm telling the operating system, I am asking the operating system to allow me to do toast. And so this is something that is used by the operating system. It's used by our certification team. When you submit the app, we verify that. You're not doing it toasts without having that in the manifest and so on. And then of course the end user sees that when they install your app, they see that you're requesting that toast capability, or in this case, yeah, toast capability. And so if you are doing toast, make sure that you set that toast capable to yes. It is actually no by default, and so if you want to do toast, you have to go in here and do that. Okay, let's go back to PowerPoint and continue on our journey to comparing the various system level stuff in Windows 8 and Windows Phone 8. So we talked about local storage earlier. One other thing that's also important is app settings. And so there are contracts for settings, but there is also a place where you want to store your settings. And unfortunately, there is no overlap between Windows 8 and Windows Phone in terms of how you do that. So when you allow your end user to choose your preferences, in Windows 8, you would use the application data class to manage settings. That's in the Windows.storage namespace. And as I mentioned earlier, you do have Windows.storage on Windows Phone, just not the application data class. So you can't use that to store your settings. On Windows Phone 8, you have the isolated storage settings class that you would use to manage your settings, and that is in the system.io namespace. And so it is quite different here. This shows a method that can save a setting to either local or remote storage. This is in Windows 8, obviously, because you can, you can do local or roaming of settings in Windows 8. You can't do that in Windows Phone. And so if I am passed a Boolean that says if it's, whoops, let me back up there. If it's local, then we will use the local settings.value key and give it the value. If it's roaming settings, then I'll use application.data.current.roaming settings.value key and then value. Windows Phone is quite different. You use the isolated storage settings, as I mentioned earlier. So here we're defining that, giving it the setting key, which we're calling music setting here. It's the in the constant music key, and then I have this property that has been set up here, and when I get that, it goes and retrieves it using the application, isolated storage settings, application settings, and retrieves that. And when I'm setting it, then again, I'm using app settings, the isolated storage settings, to actually save that to my local storage. So pretty straightforward. It's actually quite easy to do in both cases. It just happens to be quite different. And so when you are building a Windows Phone app or a Windows 8 app, you'll just have to manage that in two different areas. And we'll talk about how you do that later, or how you can separate the various system-specific things between Windows 8 and Windows Phone towards the end of the course later on today. Networking is also another area. I mean, obviously, apps are going to pretty much rely on the internet. We think that internet thing's going to catch on, so it's a good thing. So Windows 8 and Windows Phone, you need to declare that in the manifest. And so it's just a capability that you turn on. On Windows Phone, it's ID_cap_networking. And in Windows 8, it's in your package manifest. It's just the internet client. And that one's actually on by default in most of the templates on Windows 8. Now, there are a number of differences. There are some things that are the same, but there are a number of differences, unfortunately, when you are using the networking APIs. You can take advantage of some of the similarities to abstract that out, but we're going to talk about some of the differences here. So Windows 8 actually introduces a cool new API called HTTP client, quite useful, and it acts as a session to send requests to the server. So whether it's a get, post, put, whatever you need to do, and data is returned as a string, and it's all done via async, and so it's all good. And you can also do authentication using the web request handler if that's required. On a Windows Phone, this is not available on Windows 8. There's something called Web Client. On Windows 8, this is not available, but you do have something equivalent. You would use the HTTP client, which we just talked about. The Web Client is slightly different from what you may have seen in earlier versions of Windows. Here we have the example down at the bottom of the screen here, where I'm newing up a new web client and then setting the anonymous method there, and then downloading the string and then showing the results once that's done. So pretty straightforward, but not at all like it's done on Windows 8, and so you'll have to manage that between the two platforms. Now, we talked earlier that only one app at a time, whether it's Windows 8 or Windows Phone, can be in the foreground. That's not actually true in Windows 8. You can have two apps in the foreground if you use a snap view and a filled view. But for all intents and purposes, you have an app or two that's in the foreground. But there may be some pretty interesting scenarios where you may want to run code in the background. Those, for example, include streaming of music. So if I want to listen to my MP3s when I do that, or let's say I want to retrieve some files from a server for updating my application in the background, updating my cache, what have you, or if I want to download a file for whatever reason, I may want to do that in the background. Both Windows 8 and Windows Phone give you the capability to do that, and they both run on a specific trigger, and they behave independently from the app. So in other words, your app has a foreground portion to it that is what the end user would see, and then you would also define a background portion to it. The operating system has complete control over when your background task is run. And so let's look at the differences between Windows Phone 8 and Windows 8 background tasks. If we look at Windows Phone on the left and Windows 8 on the right, Windows Phone 8 tasks derive from the background agent or one of its subclasses, Microsoft Phone and Microsoft Phone.Scheduler namespaces. You basically override the onInvoke method and then call the notify complete when you're done to let the operating system know that your background task is done and they can move on to the next background task. You should always check that your background task is not already registered, and if it is, you deregister and then re-register. I'll show you how that works in a couple of seconds. And you would use the scheduled action service to add or remove background agents once you've defined what they're doing. Windows 8 is a little different. You're using the Windows.application-model.background namespace. You implement the iBackground task interface and its run method, and then you declare the background tasks in the manifest. Again, that's another capability that the end user gets to see and gets to accept as part of downloading and installing your task. Again, you check that your task is not already registered, and then use the background task builder to create and register an instance of your task. And then you make sure that you handle the background task completed in order to get data back from whatever that background task was doing. So let's look at a couple of examples here. This is the Windows 8 example here, where I have a simple background task that's implementing the iBackground task interface. And so here, I'm overriding the run method, and I'm doing stuff. And then, of course, there's also, in my manifest, there's my background task there. So when that's running, you'll see here that I am defining or I'm checking to see if the task has already been registered, and if it is, usually I would deregister it and then re-register my new task. If it's not running, we then continue and create my new using the background task builder API, and then give it a name so that we can refer to it and find it again later. Give it a task entry point, set a trigger as to when I would want that, and then I would use the register API to register that. And then I would also set my completed method, so I know that when the background task is completed, I have an event handler that gets triggered so that I can do whatever needs to be done once that background task is complete. Don't know what that might be. Depends on whatever scenario you may have defined in your case. Windows Phone 8 is a little different. You would override the onInvoke method and use the schedule task agent here. And so here I would write some code, and when that background task is complete, then I send a notify complete. That notify complete method tells the operating system that you're done with the background task, and so the operating system can go on and use the CPU or the thread for something else. And so here I'm defining that task. So I am somewhere in my code, in my foreground code is where I would launch that task. So I'm using the scheduled action service to find that background task to make sure that it's not already registered. If it is, if it's not, rather, then I'm newing up a new one. If it is, then I remove it. And so then I create my new task with the description, whatever that might be, the expiration time, in other words, how long will that task run for, and then I would add that using the scheduled action service, and then the task will run based on whatever the operating system decides. On Windows Phone, for instance, it runs every 30 minutes for a certain number of seconds so that you can do things in the background on a regular basis. So again, pretty easy and straightforward to do. There are certain scenarios where there might be a little different, streaming, for instance, or VoIP or that sort of thing. But for all intents and purposes, it's quite straightforward, but it is very different between Windows Phone and Windows 8. And so you have to keep that in mind when you're building your app, and you have to isolate that platform-specific code to the specific projects that are specific to that platform. And obviously that can't be reused. The other area is in the media capture area. Obviously, both Windows 8 and Windows Phone 8 have media capture APIs, where I may want to take a photo, for instance, and then whether that's on Windows 8 or Windows Phone 8, there are capabilities to do that, and they're different, unfortunately, between the two. They both have capture APIs that you can use, and then there's also system-provided UIs that you can take advantage of, and we'll do that in a few minutes. So looking at the media capture UI in Windows 8, Windows uses Windows 8 uses the camera capture UI to capture images and video, and basically you would have to declare that again as a capability in your manifest, both the webcam and microphone capabilities. And once you've done that, it's actually pretty straightforward. You new up the camera capture UI, and then tell it, and then you use the capture file async, and then tell it where you want to put it, and then it comes back and gives you that file, and then you can do something with that file, whatever that might be. Save it to disk, display it on screen, what have you. Windows Phone uses a different API. It's again, it's a task as part of one of the tasks, one of the chooser tasks. It's actually the camera capture task to take photos. And again, you have to declare capabilities. It's the ID cap ISV camera and ID cap _ camera phone in the manifest. If you want to do videos or capture a sound. And so here I am declaring a camera task. Here's my initialization, where I am newing up the camera task and telling the camera task when it's completed, what to do with that, and that's then calling the photo captured method. And then at some point, the end user triggers a take photo. Perhaps they click a button, an app bar button, or something like that. And so the camera task.show is what would trigger that system UI. And then once the end user is done, it comes back and it comes back and triggers it runs the photo captured method, and then you can do whatever it is you want to do with the result. Again, save it to disk or display it on screen or what have you. This is kind of neat, so let's actually go back to Visual Studio and have a look at how that works. And so let's start with, go to Windows 8 here, and we will go to the item detail page and go to here it is, on capture photo. So in my API, I have something that triggers this, and so obviously what happens, as I said, is I'm capturing camera capture UI. It comes back with in this case, it's a photo. I'm telling it to go into photo mode, and so it's going to come back with that file, and then if the file is not done, then we're going to do something. In this case, we're going to use the data transfer manager, which is what we use when we're using the share API, and so it's going to trigger that, and it's going to launch the share UI and allow me to share that with some of the other apps in the operating system. So apps that have already been installed that have implemented the share target contract. let's actually run this and see how that works. So this is the cookbook. And so let me go into one of the recipes, and let me just open it up. You can see there's an app bar button called Brag, and so I am going to take a photo. And so normally, well, actually it's giving me the option of photo or video. I'm going to use photo, which is the one we just looked at. Normally I would be taking a photo of the recipe I've just cooked so I can brag about it. In this case, I'm just going to take a photo of myself. And there I am. And so you can see that there's some system-provided UI. I didn't have to do anything other than do that. And so things like cropping, for instance, is all provided for me. And so I can crop this, click OK. Now I click OK. Remember, we're using the Data Transfer Manager to trigger a share. And so it should come back with that file, and then it should, there it is, it should trigger the share. And so I can do something with that. I can send that to Metro Twit, for instance, and just tweet that. There's my video. And so, and if I send that tweet, for those of you that are following me, you should see that tweet along with the photo. Now let's have a look at how that might work in let me close that and come back to Visual Studio and have a look at how that, something similar to that would work in Windows Phone. So if I come back to Windows Phone, let's look at the recipe detail page. Similar idea here. Actually, it's a recipe detail page. And here it is. And let's see. Oh, here it is. Okay, so right up at the top of the recipe detail page, you see there's a camera capture task. So I'm making that available. I'm doing, or making that available as part of my class. And then you can see in the constructor, I am actually doing something with that. I'm creating a new camera task and putting that into camera. And then I'm also telling it that once you're done with that, there's the camera completed. And so if I go and look at how I trigger that, there's a button take picture, here it is, button take picture click event. And so here it does that. And so basically it takes that camera object or instance that I've just created, sends the show method, and then that is going to trigger the system provided API. And if you remember, I gave it a camera completed, and so when I'm done with that, I can do something with that. In this case, I'm going to display the photo on the page in an image control called My Image. So let's actually run that, and again, we should see this. It's pretty straightforward. Okay, let me see, find a recipe here. There's some, there's just some in-app purchase stuff that's in that in this app. When you look at this app, it's actually quite nice. It's a good way to learn how to put in-app purchase in your apps. But in this case, I just wanted to get to the recipe so that I could take the photo. You can see I clicked the photo. Now, because I'm using the emulator doesn't use the webcam to take a photo, so it just gives me an image that's animated and showing me something. And if I click on that, it will take that image and then give it to me. And if I accept that, it brings it back, and it should be somewhere. There's my pictures there where it adds it to my pictures. So again, pretty straightforward, but again, not the same between Windows 8 and Windows Phone. So you have to take that into account when you are doing that sort of thing. All right, let's go back. I think we had one more section to talk about. Whoops, wrong PowerPoint. Right. The last section that I wanted to talk about is the app bar. And the app bar is, again, very similar capability or similar idea or concept between Windows Phone and Windows 8, but implemented in very different ways. The app bar is where you would implement certain very specific and common commands that you would have in your app. And typically, they would be actions that you would be doing against whatever content is on the screen at the moment. Using the Windows Phone Windows Phone application bar, and the app bar in Windows 8, you have different things that you can do in your app bar. You have more room, so you can be more creative. There's very little that you can't do with the Windows 8 app bar. It's basically a container, and you can do pretty much anything you want there. The phone, though, does have limited screen space. You can only put 4 commands or 4 buttons on the app bar, and as a result, there's not too much you can do with that. You can add additional menus. I think 6 or 7 menu items that you can add below the app bar, but it's a little bit harder for the end user to find, and so typically you want to limit the number of commands that you would have in a Windows Phone 8 app to the ones that are the most essential ones, or the ones that the end user would see most often. Let's compare how those look. So again, Windows Phone 8, there's one app bar at the bottom of the page. Windows 8 has 2 app bars. There's one at the bottom of the page and one at the top of the page. Windows Phone is very restricted and very structured. Every app bar can have up to and no more than 4 items on the app bar. Anything above that would be put on the menu. There's no way for you to group those items. It's very restrictive, right? It's 4 buttons. They're round buttons. You can do whatever you want with those round buttons as long as you're putting 4 round buttons on there. Windows 8, on the other hand, the app bars behave like containers. There is no standard menu that you can use like the Windows Phone app bar, but you can do similar things using flyouts and so on. You can also group items using nested containers within the app bar. And so you can be more creative. You can do things a little bit differently and take advantage of that. And typically, it's not a requirement, but what we're seeing mostly is that on the left-hand side of your app bar in Windows, you would typically have screen-specific tasks, and on the right-hand side, bottom right-hand side, you would have global tasks for the app. And also along the top of the app bar, along the top, you would typically use for navigation purposes. For instance, in IE, you see that when you're looking at different tabs, you would be using the top app bar to have the different tabs displayed, and so the end user can switch back and forth. The application bar control is what it's called in Windows Phone, is within the phone application page .application bar namespace, and then the app bar control in Windows 8 inside the page.bottom app bar or page.top app bar. You can set mode to default to show the app bar when the page loads on Windows Phone side. On the Windows 8 side, you set the is open property to true to show the app bar when the page loads, and set is menu enabled to enable the menu, and you can use is sticky to force the app bar in Windows 8 to show and to always remain open rather than forcing the end user to swipe up from the bottom or right click on the screen to bring that app bar with the mouse. Let's look at the XAML for that. In Windows 8, you'll notice here there are 2 stack panels that are used to group the buttons. I have one group along the left. You can see that I'm using horizontal alignment left there, and I have an edit, remove, and add button along the left-hand side. Again, those would be, as I mentioned, typically the guideline there is to use the left-hand side for tasks that are related to what's going on the screen. And then on the bottom right, you can see here my stack panel, horizontal alignment right. I have a refresh and a help app bar button. And those are more global actions that the end user might take. On Windows Phone 8, it's a little different. The application bar you're setting the properties via XAML. So here is visible, it's true, is menu enabled, true, what mode, whether it's default, the opacity, and all of those things. You can also have then various application bar icon buttons, and again, you can have up to 4 of those. and the operating system decides where to put those. It'll center them based on how many there are, and it will space them accordingly. And so here I have 4 of them, one for taking a picture, one to share, one to start cooking, perhaps it's an alarm, and then one to pin my app or maybe my recipe to the start screen. So I'm going to stop there. Let's just do a quick recap of what we've done. We've sort of taken a romp through Windows Phone and Windows 8, trying to compare and contrast those two platforms. We did look at the major differences. If you remember back to when we first started this morning, the differences between the physical devices that end users see when they are interacting with those two different platforms, and they are quite different, and as a result the user interface and the user experience between those two platforms are quite different, and my recommendation to you is not to try and reuse your XAML between those two platforms. But there are other areas where you can take advantage of similarities in the platform so that you can reuse code. In particular, you can use things like portable class libraries, and in areas such as, for instance, the data model, which we talked about earlier, when you're storing using the Windows Storage API or storage file in the Windows Storage namespace for file storage, that is the same between Windows Phone and Windows 8, Windows Phone 8 and Windows 8. And so you can reuse that by using things like portable class libraries. And there are many features that externally you would think are very similar, but actually are implemented quite differently. The developer experience is quite different. The user experience may be different. And so things like application lifecycle, tiles, media capture, tasks and contracts, all of those things are different, and so they're implemented differently, and so you need to think about that in a different way. So we're going to stop here. I think I have a question from the queue that Frank has queued up for me here. How can we set the periodic update of live tiles? So typically you would do that using a background task, and so the same way we talked about background tasks earlier, you could do that on the device. The background task is triggered every 30 minutes, and so what you do with that is up to you, and typically and very commonly you would update your live tile within the background task. You can also do that on the server side. As you can imagine, you can actually trigger a notification to come from your server to the device if you register with the notification service, and then the server can send that notification anytime. And so if you have a notification service, you're not limited by the operating system deciding when that live tile gets updated. You can actually do that on a more frequent basis. So for instance, if you are doing things like updating a news app, and you might want to trigger a live tile to change if there's some breaking news, that would be more immediate and more appropriate, I think, if it was coming from a server. Your server would be checking for a trigger, in this case breaking news, and if there was breaking news and the end user had registered an interest in that, in wanting to get that as a live notification, then you would do that via live notification via the notification service. I think I have time for one more question. Different app bars for an application, different buttons on one page than another. Yes, to both of those. You can have different app bars for application. You can have different pages may have different app bars. It's a very common scenario where, again, typically what you see on the app bar are buttons that give you commands or actions that you would take on the content that you're seeing on the screen at the moment. And so if the application page is different, then the app bars would be different. And so you would change the app bars based on the application page. And of course, the different buttons on one page and another. That's obviously something that you would do. So I think we're out of time. We're going to stop here. I think we're right on time at this point. We've actually spent the past 2 hours talking about Windows 8 and Windows Phone, comparing and contrasting those two. We're going to spend the next 2 hours talking about how you can reuse your code. We'll talk about how you can build view models to move some of your code that you may have in your code behind in your views into a view model that can then be reused across platforms. We'll talk about MVVM and how that's useful. And then finally, at the end, we'll talk about, once you have all of that built, how you can use some techniques to share that between Windows Phone and Windows 8. So stay tuned, go grab yourself a coffee. I'm going to do the same, and then we'll be back in about 10 minutes.